Hello. Well, in a moment, we're going to just take you through uh, the spreadsheet and give you a sort of overall guide to it in case you haven't sort of worked out what it's doing. But first of all, a couple of questions. Some students have asked, why on earth would someone ask students like us to do something that's as difficult as this? And the answer is because someone has to. We do need to know the answers to this or what people think the answers to this are. And the fact is that previous forecasts, no matter how eminent the institution that created them, did not take account of the extraordinary events of this year, the economic and energy effects of COVID-19. So we don't honestly expect you to make better technical forecasts than specialists who've been doing this for years, but they were driving their models with the wrong assumptions. And so their forecasts for the conclusions must be wrong, like a sausage machine. If you put the wrong things in, you're going to get the wrong things out. So you're on your own. You're going to be doing some genuine research and genuine forecasting and have a first stab at it. And why not? So we just ask you to have a go and try and make your projections for the future internally consistent. If you want to compare your forecasts with anyone else's, then remember these four things. First of all, who is this forecast? Is it some right-wing nutter group or, a front for the Chinese government or the Russian government or whatever? You need to know who exactly has done this projection and when did they do it? Was it last year or earlier this year or not? Have they taken into account COVID-19 is the key question. And then you want to look really quite hard at the assumptions. As I said, it's like a sausage machine. What you get out depends on what you put in. So what assumptions have they made that are crucial? And then, above all, look at what are their possible biases. So you've got to look at their funding. Where does this institution get its money from? Is it getting its money from the Russian government or from climate change denying oil companies or whoever? So you need to sort of do a bit of research about that at your institutions. Okay, so in conclusion, what have we done this week? We've acquainted ourselves with the assignment, I think, started to get our heads around it, learned some core concepts about making business presentations, about greenhouse gas emissions, and about how to make projections. And we've also pointed you to some good sources for assignment one. So the references are there. You can find those on the slides. So now we're going to take you just through this spreadsheet that we've created for you. So when you open up the Excel spreadsheet that we give you, you'll find that it's got some numbers and some charts. And really in this diagram, in this little talk, I'm only going to take you through the charts, but they are based on the numbers which are above. So you can see some of them are just above here. So what does this first chart on the first tab show? Well, what it shows is global carbon dioxide emissions in the past. And of course, we, up until 2020, that was the financial recession of 2009, but we are now here at 2020. And that downtick that you see there is what's actually happened so far this year. Beyond that is a projection, and this projection I've called business as usual. And that means that we have just projected it based on the same kinds of projections that were occurring from 2010 to 2019. So it's sort of business as usual and just a little tiny tick there as to what happened in a rather odd year 2020. Well, that's one projection, but you might, I hope you will, think about different projections. Okay, how might we come at those? Now this one I just want to emphasize is showing total carbon dioxide emissions by geographical region. So the blue down the bottom is Europe, the checkerboard is North America, the dotted sandy area is the former Soviet Union, the stripy area here is the Middle East, so I'm not quite sure, but it will certainly go out to say Afghanistan and places like that and include Arabia. The red is China and India and the rest of Asia and the Pacific, and the black is Africa. So that's what that diagram shows. Now, if we go on to the next sheet, this shows the same thing, but geographically. So the geographical regions are the same, but this is showing primary energy consumption by region. I explained in the last lecture what primary energy consumption is. And you can see it's a fairly similar picture, but there's no projection beyond 2020. I mean, that 2019 is the peak, and then that's 2020. That's the IEA's forecast for this year. But there is nothing beyond there because you've got to create it. Okay, but what you can see is, broadly the same thing, that the rising energy demand in Asia and the Pacific is what's driving the carbon dioxide emissions. So if we now slide across to primary energy consumption by region, so this one was a layer chart. This is the same data just done as a line chart, and you can see that well, China and Asia and Pacific is the one that's the strongest there, and that's the top. But total energy consumption has been rather flat in North America and Europe, and then slightly declining, but it's still rising in other parts of the world. And then if we go across to this diagram, this shows primary energy consumption per capita, per person. Okay, and there we see that the region in the world with the highest energy consumption is North America, up there. But it has actually been falling. That's the good news. But it is still pretty high, up at 275 or 250, and then falling. And then this is the former Soviet Union, and that was very high and has fallen now to European levels and is still quite high. This blue line here is Europe, and that has been flat, and then it's been falling recently per capita. Remember, this is. And here we have the Middle East, and the Middle East has risen up to European levels and then exceeded it. And I'm going to have to stop here because supper is calling. I will come back to you. Well, that feels better. I had some supper now. Okay, so what have we got here is a chart of per capita primary energy consumption for the world's main regions. And that link up to what we're really trying to explain, which is primary energy consumption by region. Well, this primary energy consumption, say for Asia, and the reason that that's so high is because it's the multiplication, the product of two things. One is the population of Asia, which is massive, and the other one is multiply that by the per capita energy consumption, which is that red line there. You can see that's why it's worrying, because it's so low. It's only half of European levels. And we've got to expect in the next 10 years that Asia's per capita primary energy consumption is going to continue to rise. And then when you multiply that by the 5 billion people in Asia, or 4 billion or whatever, that's a huge number. That's why this number is so high and rising. It's because of the sheer number of people. So the way we forecast primary energy consumption is numbers of people times the per capita energy consumption. There we've got some figures for the past, but we'd like to know what you think they'll be in the future. It might be likely that American per capita energy consumption will fall. Let's hope that the former Soviet Union does. Let's hope that the Middle East doesn't increase anymore, and let's hope that Europe can decrease. But the fact is that Africa, with 1 billion people, and Asia Pacific with 4 billion people, is where the big numbers are in terms of people. So that's what this next tab is that shows you is half of that, which is the population figures. So if you want to know how many people there are, and there will be in China in 2030, well, here's some forecasts. And who's made those? Well, a very reputable organization, the United Nations. Okay, so these are recent projections, and if you want to, you can overwrite them. But really, do you think you're better at forecasting global population or the population of China or Africa than the United Nations? I mean, they could be wrong, but I would say take these numbers as read. So don't argue about this bit. That's going to be, I would say, my advice to you is take that as your numbers of people in the regions, and you can see that, for example, well, there isn't much growth in China or in India, so the whole of Asia, on the other hand, is expected to grow from 4.7 billion to 5 billion, not a huge amount, but on the other hand, look at Africa, to go from 1.3 billion to 1.7 billion, so that's growing more in numbers of people than Asia Pacific. So, we've got to allow for that fact. If per capita energy consumption just stays constant in Africa, well, multiply with the number of people, and you're going to get a 25% increase in energy consumption just from Africa alone. So I would try to keep those numbers constant, and then we say, okay, well, what's the other part of this, which is per capita incomes, on the grounds that we use an income elasticity, and we say, well, per capita energy consumption might grow by the increase in income, and here's some figures for the past, and you may want to create some for yourself in the future. Well, there's a set of numbers here, and if, say, the energy elasticity were 2, and a country's income may grow by 20% between 2020 and 2030, well, then that would mean that it's likely that its per capita energy consumption might grow by 2 times 20%, which is 40%. So if you've got then a per capita energy consumption growing by 40%, and you know what it was in the base year, 2020, and you know how much your population has grown, you should be able to derive a demand for total energy. But that doesn't tell you, of course, how that demand is met. So our next slide, or tab, shows you the world's primary energy consumption by fuel, where we are today. So, of course, this is where we are today, and that is a forecast for the future. So this is nuclear and hydroelectric, and by and large they're not going to change very much, so I would tend to keep those constant. Oil, well, may change. Coal may change quite a lot. Gas may change quite a lot, and then the green up here is renewables. And what is going to control that? Well, one of the main things that you'll recall from when we looked inside the energy demand models is electricity generation. So if we look at that, we have a chart here, and this is the default assumption. So I'll just put that on the screen, and we can see that it's the same fuels there, but this is fact up to 2020, and then this is the projection. But what we've got is some modeling software here in an Excel spreadsheet, which says, well, what's going to happen to hydro and nuclear? Well, they're probably not going to change very much. And then some other assumptions. Oil's probably gently declining in electricity generation. But what about gas and coal? Well, they are the residual fuels. So then it rather depends on how much renewables grows by. And that is what this number does. So this is highlighted. This says 7%, but it's driven by, it says, well, we'll make that equal to that 7% there, which is one of 4 scenarios that you might want to consider. But if I, for example, say, well, perhaps it won't grow by 7%, it will grow by 3%, then we say, okay, well, let's make it equal to that. And now let's see what that does. And did you see the chart here just changed? And suddenly there was less green because we've got less growth of our renewables. And so gas demand has grown. On the other hand, we could say, maybe that's rather too pessimistic. Let's say that it's equal to the higher growth rate of renewables. So instead of growing at 4% or 7%, let's assume that it grows at 10%. Let's get that option there. And you notice straight away that the energy demand here has increased, or energy supplied by renewables. You can also do the same with the total energy scenario. And so say if that's not going to grow at 2%, but going to grow at 1%, then you say equals that one, put that in, and you see that's had an effect on the world electricity generation. And then you can push that through to here, and you see it's had an effect on the primary energy consumption quite a way. So there are linkages in this model. we hope it's useful. Do use it, please.